Hello everyone. Today we are going to explore an interesting concept in graph theory called the even number of odd vertices theorem. Let's get started. Now what is even number of odd vertices theorem? The theorem states that in any graph the number of vertices with an odd degree is always even. Or we can say in any graph the total number of odd vertices is even. A graph consists of vertices and edges. Vertices are nodes, whereas edges are connection between the vertices. The degree of vertex is the number of edges connected to it. For example, if a vertex has 3 edges connected to it, its degree is 3, which is odd. Let's start with handshaking theorem. It states that the sum of all vertex degrees in a graph is equal to twice the number of edges. Mathematically, it can be represented as given here. That is, the sum over all vertices V in the vertex set V of degree of V equals twice the number of edges in the edge set E. In this expression, degree of V is degree of vertex V and E is number of edges and capital V is set of vertices. Consider a graph with 3 vertices A, B, C and 2 edges connecting them. Look at the graph. Vertex A has degree 2. This means it is connected to 2 edges. So vertex A has an even degree. Vertex B and C has degree 1. This means it is connected to 1 edge. Therefore, vertices B and C have odd degrees. Now calculate the sum of vertex degrees. Degree of A is 2. Degree of B and C is 1. By adding the value, we get 4. Calculate the number of edges. There are 2 edges in a graph. According to handshaking theorem, this sum should be equal to twice the number of edges. So multiply the number of edges with 2. Therefore, we get 4. Now this example clearly demonstrates the sum of vertex degree, which is 4, is equal to 2 times the number of edges. Let's break down the proof. For that, separate the degrees. We can separate the vertices into 2 groups, odd degree vertices and even degree vertices. Odd degree vertices will have odd number of edges. Even number vertices will have even number of edges. So we can rewrite the above equation as given here. Now substitute the right hand side of the equation we derived to the original handshaking theorem equation. That is in equation 1. Rearrange the equation to isolate the sum of odd degrees. Now understand these components. This part consists solely of even integers, since all vertices counted here have even degrees. Therefore, this sum is also even. Next, this term is always even because it counts each edge twice. Look at the right side of the equation. It is the difference between 2 even numbers, which will be always even. Since the right side is even, the left side must also be even. Even though we are summing odd numbers, the result will be even. This can only happen if there is an even number of odd degree vertices. Now let's see an example. Consider a graph with vertices A, B, C, D and E. And its edges are AB, AC, AD, BD, CD, CE. Calculate the degree of each vertex. A is 3, which means it is connected to B, C and D. B is 2, it is connected to A and D. C has 3, it is connected to A, D and E. Similarly, D degree is 3 because it is connected to A, B and C. E has 1 as it is connected to C. Now calculate the sum of degrees. It is 12. Now count the number of edges. The graph has 6 edges. Confirm with handshaking theorem. Substitute the values. We get 12. The calculation confirms that the sum of vertex degrees is equal to twice the number of edges. Next, count the odd and even degree vertices. Odd degree vertices are A, C, D and E. We have 4 odd degree vertices, which is even. Now count the even degree vertices. The graph has only one even degree vertex, which is B, and that is odd. And now we have verified that the total sum of degrees of odd vertices is even. Let us calculate the sum of odd degree vertices, which are 3 plus 3 plus 3 plus 1 equals 10, which is even. And number of odd degree vertices is also even. Look at the graph. The vertex A, C, D and E are odd degree vertices. Therefore, the total number of odd degree vertices is 4, which is even. According to handshaking lemma, if the sum of vertex degree is even, then the number of vertices with odd degree must also be even. And this example effectively illustrates how the theorem holds true in practice. That's all for this session. Thank you so much.